Hi guys, in this video we're going to start talking about stats and probability. So in this video I'm going to refer to section 11.2, which is going to be talking about theoretical and experimental probability. Okay, so one thing that we're going to talk about quite a bit is something called the sample space, and all that is all the possible outcomes of a chance event. Okay, so for example, chance events are things like flipping a coin, rolling a die. So when you flip a coin, there are two possible outcomes, right? Heads or tails. So that is our sample space. When you roll a die, right, a single die, there are 6 different numbers. So 1, 2, 3, 4, 5, and 6 are the sample space. Now if you flip 2 coins, so I'm going to use H for heads, T for tails. So let's say I flip a coin and I get heads. Then I flip my second coin, I could get heads or tails. If I flip the first one and got tails, flip the second one, I could get heads or tails. So my possible pairings, I could have got heads, heads, heads then tails, tails then heads, or tails then tails. So this is my sample space. So there are 4 different outcomes. Okay, now rolling 2 die is kind of similar. I'm going to set this one up a little bit different. So let's say I have on one die, I have 1, 2, 3, 4, 5, and 6 as my options. On the other, we have the same thing. Okay, and so if I roll 1 die and get a 1, the second one get a 1, that would be 1 pairing, right? 1 then 2, 1 then 3, 1 then 4, 1 then 5, 1 then 6, right? And then we could go on and on with all 6. So you can see I'm going to fill every single square. So I have 6 going this way, 6 going this way. So if I kept that pattern continuing, there would be 36 outcomes. Okay, I should say 36 possible. Okay. Drawing a card, you guys will see these problems a lot in probability, so it's important to know what a standard deck is. So there are 52 outcomes. I'll say 52 cards in a standard deck. Okay, and that is the total outcomes. So within that deck of cards, there are 4 suits, okay? And the 4 different suits are, we have hearts and diamonds, which are both red. Then in each suit, there are, here's my other suit. Then we have spades and clubs, which are both black. Okay. And then within that, we have some different numbers in each suit. So each suit has 13 cards. And here's where those 13 are. So we have numbers 2 through 10. Then we have Jack, Queen, King. I'm going to use some abbreviations here. And then we have Ace, okay, or A. So these 3 right here, we call the face cards. Okay, so it's important to know those because we're going to be referencing a standard deck of cards a lot, so it's important to know what comprises a standard deck. Okay, so we're going to specifically be talking about probability with some of these random events. So this is how we'll notate it. This means probability of an event. And how we find the probability is it's the number of ways to get success, number of ways to success, that's what I'll put here, divided by the total number of outcomes, which is our sample space. Okay, and that's theoretical probability. So the thing about this is only valid in the long run. So short term is unpredictable, but in the long term we can see some patterns. So short term unpredictable, but patterns emerge over time. Okay, with experimental probability, this is something where people use simulations to actually run experiments for how many times things might occur. So it's how the number of times an event occurs over the total number of times. And again, that's experimental because they're actually running an experiment and performing the said event multiple times. Okay, so comparing theoretical and experimental probabilities is the basis of statistical inference. So it's kind of like making those two meet in the middle. Okay, so we're going to do some examples of mostly theoretical probability. Okay, so the event must be between 0 and 1, the probability. So 0 means that it's impossible. It is not ever going to happen. If the probability of something is 1, then it's certain, okay? So 100% certainty. If it has a probability of a half, then it's just as likely to occur as it isn't. Okay, so we're going to actually calculate the probability here, you guys. We're drawing one card from a standard deck. So this is 52 cards, 4 suits, 13 cards in each suit. Okay, so they're asking what is the probability of red? So remember, we have 2 suits that are red, we have diamonds and hearts. That makes up half the deck. So out of the deck, 26 of the 52, or 1/2. So typically we'll write probabilities in their reduced form, but it's kind of nice to see where you got it from. So showing this step on an assignment would be helpful. Okay, probability of getting a 10, drawing a 10. So in each suit, right, there's numbers 2 through 10, Jack, Queen, King, Ace. So in each suit, I have a 10. So there are 4 10s out of the 52 cards. And again, if I reduce that probability, it is 1/13. Okay, different scenario. In a family of 3 children, what is the probability that you have 1 girl? So this is called a tree diagram that we're going to create. So 50% chance of having a boy or a girl. So for the first child, we have boy or girl, right? And actually, I'm going to give myself just a little more space, I think, you guys. Okay, boy or girl. Okay, then after that, so let's say we have boy first, then child number 2, boy or girl. Child number 3, boy or girl. So we kind of have these branches coming off of all. We can do the same thing with the girl. If we had a girl first, okay, sorry, I'm kind of running out of room. Boy, girl, boy, girl. So each kind of layer, this is child 1, child 2, child 3. So we want the probability of 1 girl. So each like branch connecting is like 1 possibility. So here's 1, boy, boy, boy. We want what's the probability of 1 girl. So here I have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 outcomes. This actually comes from 2 to the 3rd. So there's 2 options and we're having 3 children. So that's kind of where that comes from. Okay, so how many of those options have girls? So I know it's going to be out of 8 because there's 8 total outcomes, but how many are girls? So here is, let's see, we have boy, boy, girl is a 1 girl option, right? Boy, boy, girl, boy. Here we have girl, boy, boy. And that is the only option. So here, those are 3 possibilities. So that is our probability, 3 out of 8. Now we want the probability of 2 girls. So I'm going to use the same tree, probability of 2 girls. So we could have boy, girl, girl. I think that's the only one up here. Girl, boy, girl. And girl, girl, boy. So this one is also 3 out of 8. Okay, different scenario. Travel at Thanksgiving survey from a sample of 50 people. So going to Thanksgiving, total 50 people were surveyed. 41 took a car, 6 took an airplane, 3 took a train. So what's the probability that of those 50 people that the person drove? It's 41 out of the 50. So this would be an experimental probability because they actually did a survey, and that's a legitimate experiment with a finite number of people. Okay, the other thing you guys will hear is the complement of an event, and it's what is the probability that it's not happening, okay? So this is the notation, so probability of an event C as that superscript. So this is always, because the probability at the most can be 1, so it's just 1 minus the probability of that event. So we're just calling A that event, okay? Also, if I add the probability of an event to its complement, it will always equal 1. Okay, so probability of rolling a 1 on a die. So there's 1 out of 6 options, so 1/6 is that probability. So probability of not rolling a 1 is this complement. So the easiest way to do it is just 1 minus that, which is 5/6. So it's every other option besides a 1. So it's always 1 minus whatever that given probability is. Okay, that's it for the intro here, you guys. Thanks for watching.